Okay, so diameter of a circle is a segment that goes all the way across to the center. The best example of diameter here would be segment MN. You could also say NM, it doesn't matter, but those two letters make up that segment. Okay, then it says name a radius. A radius would be a segment that goes from the center to the outside halfway across. There's a couple different radiuses, but the one that stands out to me would be this segment right here. You could call that LO or OL, either way. Segment LN would also be a radius, and so would LM. The next word is chord. This was a new word for us. A chord is a segment that goes all the way across, but doesn't necessarily go through the center of the circle. So the best example here would be PQ. And then the next part, it says if the length of MN is 6 units, so I look for MN. MN is the diameter here. So if the diameter is 6 units, then what is the length of LO? Well, LO is the radius. So to find the radius, you just do 6 divided by 2 equals 3. So it'd be 3 units. So if this is 6, then this is 3. Okay, next we are going to find circumference. What is the circumference of the circle? It says the diameter of the circle is 26 centimeters, so diameter equals 26 centimeters. It says use 3.14 for pi. Do not round your answer. Okay, so we're going to find this equation. Find equation on reference sheet. So we're looking for circumference. So if you're doing a standardized test or the SATs or the EOC or anything, you want to find circle, circumference. C stands for circumference. If you didn't know that, also over here, C equals circumference. There's two equations. We've been using this one the whole year, but essentially these are the same because 2 times radius would be diameter. But I'm going to write this equation down on my paper. Circumference equals pi times diameter. Here it says use 3.14 for pi. And then diameter, it says is 26, so we write that down. Then multiply the two numbers in a calculator, and it comes out to 81.64. Circumference is the distance around the shape, so it's just a length, so our unit is just centimeters. It's not like centimeters squared or anything, because it's just a length. So over here, 81.64, and then you click this to get centimeters right here. Okay, the next one's only on the honors test, so we'll skip that. And then go down here. Okay, so for this one, it says in the circle below, F is the center of GI, and F is the center, GI is the diameter, GH is 60 degrees arc GH, and it shows that there. Use this information to fill in the blanks. So it says, give an inscribed angle. What an inscribed angle is when you have a circle like this, and an inscribed angle goes all the way across the circle. So that's what I'm looking for, and I would say GIJ would be the best example of that. You could go backwards if you want, J-I-G. And then a major arc would be more than halfway around, So I'm looking for an arc that goes more than halfway around. Maybe J-I-H would be a good example. J-I-H. Oh wait, I'm putting in them stuff. J-I-H would be a good example of a major arc. And then a minor arc would be less than halfway around. So maybe GJ would be good. GJ. Okay, and then it says find angle GFH. So identify that angle, GFH. It's a central angle. It shows us that the arc is 60 degrees, so therefore the central angle would be 60. So the measure of angle GFH would be 60 degrees. And last but not least, arc GJH. So you're going to connect the dots. GJH is all the way around except for this little pi piece here. So all the way around a circle is 360. So we can just subtract this little part, 60, and get this part. So it'd be 300 degrees. Okay, the next question is very popular on standardized testing like PSATs, ACTs, SATs, so I'm glad it's included. You'll only have one like this on the actual test. However, on this review, we put two of them because it asks slightly different questions, but the setup is similar. So for this question, you're going to set up a proportion. Set up a proportion. You worked a lot with proportions in middle school. What a proportion is that you set it up like part over whole equals part over whole. And then you'll cross multiply to figure out whichever part you don't have. So in this case, it says there are 300 members of a university fraternity by their majors. The information presented in the circle graph, find the central angle x degrees here for business. Do not round. Okay, so we're looking for business. It says 36 people are in business out of 300. So we set this up 36 out of 300 people, part over whole, equals part over whole. So we're trying to find x degrees. All the way around the circle would be 360 degrees, so part over whole. And then from here to solve it, we're going to cross multiply like this. 300x equals 36 times 360, which is 12960. Then divide by 300, and x equals 43.2 degrees. So that would be the degrees of this pie slice. I don't know, I put proportion. Okay, then flip to the back. When you're ready. Okay, so this is a similar problem. This time they're looking for the percent. So again, we're going to do part over whole equals part over whole based on what they gave us. They said 375 books sold last week. Circle graph summarizes these books by genre. The central angle is 83.52. It shows that right here for self-help books. What percentage of the books were sold? Do not round. Okay, so we're going to take this degrees, 83.52 degrees, part over whole, over 360 degrees, which would be all the way around. We're trying to find the percent this time. So it'll be x percent over the whole would be 100%. And then from here, we cross multiply. So we'll get 360x equals, this times 100, 8352. Divide by 360 on both sides. We get x equals 23.2 degrees. Oh wait, why did I say degrees? I mean percent, sorry. Okay, the next problem here is arc length. Arc length. We are going to find the length of an arc. And the equation for this would be the arc degrees over 360 degrees, part over whole. times pi times diameter, which is the circumference of the circle. So we want to find the whole circumference and then just find the part of that we need. So first of all, we have to identify what arc they want us to find. They want us to find the major arc LNM. So I trace that LNM right here. I need to find the degrees of this arc. It shows this part 70 degrees. All the way around would be 360. So I can do 360 minus 70 to get 290 degrees for that arc. Okay, so 290 degrees. So that's what I'm going to set up in my proportion here. 290 over 360 degrees times pi times diameter. It says given an exact answer in terms of pi, and then diameter, it says the radius is 5 feet, radius is 5 feet, so diameter would be 10 feet. So pi times 10. Once I have it set up like this, I can just multiply to solve. If it helps you can put this over 1. When you multiply fractions, just multiply across. 290 times 10 would be 2900. You leave pi as it is because it says to put the exact answer in terms of pi over 360 times 1. This is your answer here. It will accept this as a correct answer, but as you probably realize, you could simplify this as well. One way to simplify it would be using a calculator. So in the calculator, you can do 2900 divided by 360, and then turn it into a fraction and an improper fraction, and you get 145 pi over 18. 145 pi over 18. Oh, and then the unit would just be a length, so it would be feet. Okay, then the next one. The next one is a bunch of equal parts. So it looks a little bit complicated, but once you label things, it gets a bit easier. So it says JK is 19. So from here to here, 19. LK, this length, is 3x plus 1. SN is 12, and SP is 12. Find the following. We need to find x first. Since these segments are the same length, that means that this chord is equal in length to this chord, and we can set these two things equal. So 3x plus 1 equals 19. Subtract 1, 3x equals 18. Divide by 3, x equals 6. Then it asks for the length of JN. JN would be just this part of the segment here. These segments, these diameters bisect this segment, so like this is the same length as this over here. We can take 19 divided by 2 to get the length of JN. 19 divided by 2 is 9.5, so that is our answer. Okay, circle below has center D. Suppose that measure of BC is 98. Find the following. Okay, the setup for this comes up quite a bit on standardized testing. The way it's usually set up, this example is a little weird visually. The way it's usually set up is you have a circle, and then in that circle you have like a central angle like this, and then you have an inscribed angle that goes all the way across the circle like this. And those two angles have the same intercepted arc right here. So how it usually works is like this angle is 60 degrees, so that would be the same as the arc. And then this inscribed angle is half of the arc, so this would be 30. So whatever this angle is, this is half of it, and vice versa. Like this would be double this angle over here, because they have the same intercepted arc. So that's what they're looking for here. It's just visually, it's kind of weird. Like this would be the central angle, like it is here. And then this here is the inscribed angle that goes all the way across. So this angle is half of that. So here it says measure of arc BC is 98 degrees. So that means the central angle is 98 degrees as well. And then this inscribed angle is half of 98. 98 divided by 2 is 49 degrees. So this here is 49 degrees. And then here, angle BDC is the central angle, that is 98, and BAC is 49 degrees. Okay, the last one here, it is an inscribed quadrilateral. Inscribed quadrilateral. That means the quadrilateral is drawn inside the circle and the endpoints meet the circle. In an inscribed quadrilateral, opposite angles are supplementary. That means they equal 180 degrees. Okay, so that's the first piece of information we need to know. Now we're going to look at what they gave us. They said arc RQT. Notice how it says arc. RQT right here is 142 degrees. If that arc is 142 degrees, then the inscribed angle that has that intercepted arc will be half of that. So 142 divided by 2 is 71 degrees. So this angle is 71 degrees. And then it says angle QRS is 69. So this is 69 degrees. Here it wants this angle, we'll call it X, and this angle, we'll call it Y. Okay, and we learned that opposite angles are supplementary, so we can do 180 minus 71 is 109 degrees. So RQT 109 right here. And then these two angles are supplementary, so we can do 180 minus 69, and that comes out to 111 degrees. And then we answer our questions. RQT is 109. QTS is 111 degrees. And that's all. Okay, so your to-do list. Leave out practice tests so I can grade it. Yes. So I can grade it. And then work on the practice test on ALEKs. On ALEKs, the chapter 10A practice test. Okay.